Hey everybody, this is Mr. Kinney. We're going to go over the mixed mole problems. I'm going to do the odd ones for, the even ones first, and then I'll do the odd. So, this is just how to get them set up. Zoom out here. I hope my zoomer outer will work. So I don't get mixed up here. 2, 4, 4, and 6. So we're working in stoichiometry. We're working with our friend the mole. And what the mole does, it allows us to convert between grams, liters, and number of atoms or molecules, depending upon what you're working for. So it's really nice because the mole is a really great conversion factor here. It lets us link all different stuff together. Now, on the mixed mole, you're going to be going back and forth around this. I like to use this MVP triangle, mass, volume, particles, as your road map. So the first one, what volume? Okay, so you're looking for volume. You're going to end up on this part of our road map. Would this many molecules occupy? So we're starting down here with molecules. So to go up here to volume, we're going to have one conversion factor, which, look at there. There's the conversion factor you're going to use. 1 mole is Avogadro's number of particles. Then once you've converted it to moles, we have the second factor, conversion fraction, and it's right here, 22.4 over 10. So you've got two. So you've got two fractions you got to set up on there. So our given, let's go back to our given. The given here is 1.2 times 10 to the 24. So you'd enter that in your calculator, 1.2 EE 24 over 1. Let me zoom in here now a little bit. Hopefully my autofocuser hasn't been working the best. Oh, there you go. Okay. So that's our given. We always start with what we call the given. Now we've got to have two conversion factors because we're starting here and we're going there. I'm just going to go ahead and put them in now. Want you, when you're working with these problems, to kind of be looking ahead. Look at the roadmap. I even gave you a little one there. It's kind of hard to read. Sorry. You need two conversions. Oh, wait a minute. I didn't properly label. This is molecules. M-O-L-E-C-S. Now, it's not specific, just molecules of a gas. Now, it does say at STP, at standard temperature and pressure. So, our first step is, and the STP doesn't really matter for this problem. Well, I guess it does in the second step. So, we want to go from number of molecules to mole. So we want to put Avogadro's number of molecules down here times 10 to the 24 molex. I abbreviate molecules, molex, in 1 mole of, I guess since this is STP, where I guess it would be a gas, actually. I guess this would be. So I'll just say 1 mole of a gas. And Avogadro's number of a gas. And molecules of a gas. All right. So at this point now, we can cross off molecules of a gas with molecules of a gas. We've set this up correctly. That's what's so nice about putting these units on there and crossing them off. So at this point, we have converted from molecules to moles. Now we just need to turn it into a volume of gas. And at STP, 1 mole of gas, and we've got, is how many liters? Right. 22.4 liters of gas. And if we set this up right, the moles of gas cancel and the moles of gas cancel. So you're going to have, well, let's, oh, you know what now, before you do the math, we've got times 10 to the 24. We've got times 10 to the 24. We can actually even cancel the times 10 to the 24. Just makes it a little easier. This becomes 1.2 times 22.4 divide 6.02 now. So there you go. Next one. What is the mass? We're looking for mass. We're going to end up on this part of the MVP triangle. Does a sample of an H3 gas, that's ammonia, which occupies 11.2 liters at STP. So what they're saying is this is our given. Okay, we're at standard temperature and pressure, and this is how much we have. So like any problem in stoichiometry, our given is 22 liters, and it's a gas. Okay, I'll just put NH3 on there. So that's our given, over 1, 11.2 liters. And so we're up here. So now we're going to just do the opposite of what we did before. If we're going to come to the mole, now what we're doing, we're dividing by the 22.4. And that makes it 22.4 liters in the denominator and 1 mole of the gas up there. So, okay, there's liters, 22.4 liters of NH4, excuse me, NH3, sorry, I'm thinking of ammonium, you don't care, is 1 mole of NH3. So let's see, liters of NH3 cancel, liters of NH3 cancel, excellent. Now we've got one more conversion because all we've done at this point is we've just brought this down and converted it into a mole. Now we need to change it into mass. Yeah, molar mass. That was where you have to use the periodic table. So we're going to say here 1 mole of NH3. And so you got to look on your periodic tables. Fortunately, I have a lot of them. Okay, nitrogen is 14. I'm just going to put a 14 above that. Hydrogen is 1, we know that. There's 3 of them, so that'll be 14 plus 3 is 17 grams of NH3 is 1 mole. That's the molar mass. This is called the molar mass. So at this point now, we've got 11.2 divided by 22.4. And actually, I think we know we can cancel that off and say it goes in there twice. It ends up being 17 divided by 2. For the last one on here, we've got a 24-gram sample of O2. Okay, so now we're starting here. We've got 24 grams of O2. And, okay, it's in a sealed container at STP, all right. What is the volume of the container? So we just need to figure out the volume of the container. So let's see, our given is 24 grams O2. It's really important that it's O2 because we're going to need to figure out molar mass. You can't just put oxygen by itself. There's our given. And since we're starting here and we want to convert to moles and then to volume, we're going to have 2 conversion fractions we need to multiply it by. So I'm just going to get those set up. Okay, so let you know you got to have 2 of them. We want to get rid of grams there, so we need to figure out the molar mass now, because if you look at this chart to kind of help you out, we need to, our conversion factor is going to be 1 mole of O2 gas divided by its molar mass. So let's see, 1 mole of O2 gas, well, oxygen, when we look on the periodic table, its mass of just 1 oxygen is 16, so since we have 2 of them, 32 grams of O2 is 1 mole of O2. So we're multiplying our given by the reciprocal of the molar mass. Now, if we did this right, grams of O2 cancel out there. So, what's the next step? We are at moles, and we wanted to get to volume, and we are at STP, so at STP, we know that, oh, look at there, we're going to multiply by the factor of 22.4 liters of a gas over 1 mole of a gas at STP. So we can say 1 mole of O2 is going to be 22.4 liters of O2. So the moles cancel, and looks like we've got 24 times 22, divide 32. We'll give you your answer. Now, for tonight's homework, you are looking for grams. So you're starting here. You're starting at grams. I'm sorry, I beg your pardon. You're looking for grams. You're going to end up right here. They're giving you number of molecules. So on this one, you're going to start here. You follow the arrows. You're going to actually divide by Avogadro's number to convert it into moles. And then when you come this way, you're going to have to multiply it by the molar mass of CO2. Sorry, that's in the wrong spot. So when you get that set up, you're just going to put the given written right here, and you're going to multiply it by this conversion factor and then this one. Now the molar mass of CO2, just to refresh your memory, carbon is 12. From a previous problem, we know that O2 is 32. That's 16 times 2. So when you add those up, let's see, 2 plus 2 is going to be 4. 44 grams per mole is the molar mass. And you'll need that when you finish up this one because you got to multiply by that. In number 3, sample of NH3 gas occupies this many liters. How many molecules? So what we're doing is you're starting here at liters. You're going to divide by 22.4, and then you're going to multiply by Avogadro's number to end up with number of molecules. Number 5. How many molecules are there in 2.5 moles? Well, you're looking for molecules, so you're going to end up here. Oh, but this is short. They're giving us 2.5 moles. So this is just going to be a one-step conversion. We've got the given, then we're just going to multiply it by Avogadro's number to turn that into molecules. That'll be pretty easy. And lastly, you have a 33.6 liter sealed container of gas. Okay, that is your given. And you are going to convert it into how many molecules? So you're going to convert it to moles. So you have one conversion fraction. It'll actually be this one over here. And then you're going to have to multiply it by Avogadro's number. Right? We're looking for number of molecules. So there you go. That's how you get those set up.